Here's a video for Note 7-2, Graphing Systems of Inequalities. So in the previous lesson, we learned about graphing systems of equations, and we talked about how the solution when graphing is a point of intersection, and that point, that x and y value should make both equations true in the system. Well, the solution to a system of inequalities, we know that when we graph an inequality, we have some shading areas. Well, the solution when graphing are all points in the overlapping shaded regions are going to be our solutions. And when we plug in any point from the shaded region, a solution will make all inequalities in the system true. All right, so it says graph the following system of inequalities and plot and label one solution on the graph. Show algebraically that it is a solution. So one thing I do recommend is that you use two different colors when graphing this so you can easily determine which line is which. So what I'm going to do is I'm going to graph each line and then shade, and I'm going to do the other line and then shade. So starting with the first line, I'm going to graph in red. So y is greater than x minus 3. So first thing, I'm going to start at -3. And then my slope is 1, or 1 over 1. So I'm going to go up 1 to the right 1, up 1 to the right 1. I'm going to keep going in that pattern in both directions. All right, since it's just a greater than symbol, not greater than or equal to, we're going to use a dash line. And now we're going to shade. To the shade, we're going to plug in our test point, which is 0, 0. So it's going to be 0 is greater than 0 minus 3. So that 0 is greater than -3. That's true, which means that we are going to shade this side of my line. Okay, next line I'm going to graph in blue. So we're going to start at +4. My slope is -2 over 5, which means I'm going to go down 2 and to the right 5. Down 2 to the right 5. And then I'm going to go in the opposite direction. All right, this line is going to be solid since we have a line underneath. And then again, our test point we're going to choose is 0, 0. So it's going to be 0 is less than or equal to -2 over 5 times 0 plus 4. So this is going to become 0 is less than or equal to 4. That is also true. So I'm going to shade that side of the line. So now what I'm going to do is I'm going to highlight my overlapping region in yellow. So the area where I see both red and blue, that's going to be my solution area. So let's write nice and big in here that this is the solution. Okay. So now it says plot and label one point and show algebraically that it's a solution. So I'm just going to pick a random point, maybe right here. And let's see, that is -6, 4. So now what we're going to do is we're going to plug that into both equations and make sure that that's true. So making sure that when we plug this in, we plug the first number in for x and the second number in for y. So starting with my first equation, y is greater than x minus 3. So we're going to plug in -6, 4. So it's going to be 4 is greater than -6 minus 3. So that's 4 is greater than -9. That is true. And now we're going to plug it into the second equation. So y is less than or equal to -2 over 5x plus 4. So I'm going to plug in 4 is less than or equal to -2 over 5 times -6 plus 4. So this might be a case where since we have a fraction, we might want to go to a calculator for this one. So as you can see, I plugged it into a calculator, the right-hand side, -2 over 5 times -6 plus 4 gives us 6.4. So this is going to be 4 is less than or equal to 6.4, and that is also true. So there's the work to show that that is a solution. So just to make sure we understand, we were plugging in this point -6, 4 in for x and in for y. So we plugged it in for x and in for y in our equations. And since it made both of them true, that's how we verify that that, in fact, is a point that is a solution. In fact, if we chose any point within this shaded region, keeping in mind that this does go infinitely in this direction, any point in this area would be considered a solution. All right, so this says, which of the following is a solution to the systems of inequalities? So let's go through each point and plot them. So 0, -1. So 0, -1 is right here. So that point, although it looks like it's kind of in the shaded region, one thing we have to keep in mind is that that red line is a dashed line, which means that that point is not a solution. So we're going to say no for that one. The next point is 3, 1. No, that's only a solution to the blue inequality. -3, 4. So -3, 1, 2, 3, 4. That is not a solution to neither inequality. 1, -5. That is a solution since that is in the overlapping shaded region. And then -4, -2. -4, -2. That is only a solution to the red inequality. And now to answer the challenge question, what are the inequalities that we see here? So first thing we need to do is write the equation of each line. So first I'm going to do the blue line. And I see that we begin at -1. So remember our equation is something y equals something x and then plus or minus something at the end. So it looks like we're subtracting 1. And now for our slope, we go up 2 over 1. So my slope is going to be 2. I know that when we do our line that there's going to be a line underneath my inequality since it is a solid line here. And then if we look and see, did we shade below or above the line? We shaded below, so that means it's going to be a less than or equal to sign. So the equation of the inequality is y is less than or equal to 2x minus 1. One thing you can check is plug in 0, 0, and as we can see, it's not shaded, so it should make this inequality false. So if we plug in 0, 0, that's going to become 0 is less than or equal to 0 minus 1. So 0 is less than or equal to -1. That is false, so that's how I know that that's correct. Okay, so there's the first inequality. Now I'm going to do the red inequality. So again, I'm going to write my equation, y equals something x, and then plus or minus something at the end. Our y-intercept is -1 as well for this one. And now for my slope, it looks like I go down 1, 2, 3. So -3, and then I go to the right, 1, 2, 3, 4. So -3 over 4x minus 1. My inequality, I know, is not going to have a line underneath since this is a dashed line. And then we need to figure out which direction. So again, the easiest way to determine is to decide, did we shade above or below this line? Since we shaded below the line, I know that that's going to be a less than symbol. But let's just verify. So again, 0, 0 is on the false side. So when I plug in 0, 0, it should make this inequality false. So that's going to be 0 is less than 0 minus 1. 0 is less than -1. That's false. So that works out to be the correct way to write the inequality. So my equation for my second inequality is this. All right, I'm going to do one more practice problem. So first thing I'm going to do is I'm going to graph the inequalities. I'll graph the first one in red. So we're going to start at -2. My slope is -1. So I'm going to go down 1 to the right 1, down and to the right, down and to the right. And I'm going to go the same thing in the other direction. This is going to be a dashed line. And now we're going to shade. So looking at my inequality, I think I'm going to shade above the line, but let's just plug in 0, 0 to see if that makes it true or false. So 0 is greater than 0 minus 2. That is a true statement, and here was my test point. So yep, I am going to shade above my line since it's a greater than symbol. All right, now I'm going to plot my second one. So I begin at 2. My slope is 1 over 3. So I'm going to go up 1 to the right 3. And the same in the other direction. This is going to be a solid line. And now I'm going to graph. So it looks like a greater than or equal to symbol. So my intuition is telling me that I'm going to shade above the line, but let's plug in 0, 0 to be sure. So it's going to be 0 is greater than or equal to 1. Well, let's just say we know that anything times 0 is 0. So it's just going to be 0, 0 plus 2. So 0 is greater than or equal to 2. That is a false statement. So here was my test point, which means this entire side is false, which means I'm going to shade above my line. So my intuition in the beginning was correct. So now I'm just going to highlight the overlapping region to emphasize what is the solution. And in this problem, it does say to identify one solution to the system. So let's say this point right here. So that's a point 1, 3. And now we're going to plug it in. So starting with the equation on top, it's going to be 3 is greater than negative 1 minus 2. So 3 is greater than negative 1 minus 2. That's 3 is greater than negative 3. That's true. And now we're going to plug it into the second equation. So it's going to be 3 is greater than or equal to 1/3 times 1 plus 2. Well, 1/3 times 1, that's 2 1/3. So 3 is greater than or equal to 2 1/3. That's also true. So when we plug in this solution here, we plug it in for x and y in both equations. So here it is plugging it into the first equation, and here it is plugging it in to the second equation.